Take a look at 2.2, comparing pizza prices and scaling rates. Now, we have used fractions, percents, ratios to make comparisons, to make good decisions. And now we're going to be continuing that, but answering different, probably more complex questions, okay? So first of all, take a look at all of these scenarios, these 4 scenarios. Take a minute and look, and you're trying to figure out what is being compared. So there are 2 variables that are being compared to each other. What are those 2 rates or variables that are being compared? So go ahead and pause the video and try to figure out for each one of these statements what 2 things are being compared. Okay, on the first one, you're comparing, in this case, you need 2 sandwiches for each person. You're considering how many sandwiches for each person. So you have 2 sandwiches for each person. So those are the 2 things being compared in that first one. And the second one, I earn $5.50 per hour when I babysit for my neighbor. Well, the 2 things being compared is how much you make and then how many hours. So those are the 2 things being compared. So again, you'd be able to set up ratios for all of these. So for that first one, your ratio would look like this. It would be how much you're making, that's $5.50, over how many hours, so this is in 1 hour. And the third one, mystery meat in the cafeteria has 355 calories per 6-ounce servings. So you're comparing calories to servings in that one. And then Akira's top running rate is 8.5 kilometers per hour. Well, the key words in all of these is right here, the per. So you're comparing kilometers and hours. So if there's a per in between 2 rates, those are the 2 things that you're comparing. All of these, like this right here, this represents what we know as a rate. Go ahead and pause the video and define a rate to your understanding right now. Okay, so whatever you said rate was, you should have had something like a comparison of 2 quantities that are measured in different units. Like you can't compare dollars to dollars. It doesn't really make too much sense. So let's go ahead and get started. Let's look at today's problem or story. It says Julia is in charge of ordering pizzas for a camp dinner. She wonders whether to order the pizzas from Royal Pizza or Howdy's Pizza. Each pizzeria allows customers to use the same pricing rate for fewer or more pizzas than the listed number. So go ahead and take a look at these and understand the 2 different pricing cost structures. And we're going to use these ads to answer a lot of questions, and we're going to create these things called rate tables. Now, I know you've done rate tables in the past, but this is essentially what a rate table would look like. You would compare those 2 quantities. So let's say we would take this $5.50 per hour, and you would create a table of those 2 quantities. So you would say the top, and you can do vertical rate tables or horizontal rate tables. I usually prefer to do horizontal. So you compare dollars to hours, right? So after 1 hour, you make $5.50. Then after 2 hours, you would make $11. After 3 hours, you would make $16.50. And then you would keep going forever, how long the problem wants you to continue going. All right, and you're comparing quantities that way. So that's kind of what a rate table looks like. So we're going to be constructing rate tables for this investigation. On the first one, it says, as the campers plan their pizza dinner, they need to calculate the costs for many different number of pizzas. Copy the pizza price table below, but you have a lab sheet. So let's jump over to your lab sheets, and we're going to answer these questions on your lab sheet. So here's our lab sheet, and it's got the graphics for the 2 different pizza places up there, and it's got a rate table here. So let's go ahead and answer number 1. It says copy and complete the prices for each of the numbers of pizzas shown. So go ahead and do that. Complete this rate table. So for the price of the Royal Pizza, if one of these is $120, or sorry, if 10 of them were $120, then one is going to be $12, and then you can fill out the rest of the table from there. For the price of Howdy's Pizza, 15 of them are $195, and so one is going to end up being $13. And you can fill out the rest of those from there. Now, there are different tricks as you're filling this out, so you don't have to, like, for example, once you have, let's go 130, you know that 10 of them are 130, and you're trying to figure out what 100 of them are. Well, you multiply, it's just a scale factor, multiply 10 by 10 to get 100, so you also multiply 130 by 100 to get to 1,300 cost for 100 pizzas. And then you would multiply this by 20 to get 2,600, because you would multiply 10 by 20 to get to 200. So there are shortcuts if you understand that this is basically scale factors all over again. Now let's go ahead and answer the questions below. The first question says, how much will 53 pizzas cost from pizzas from Royal cost? Explain. Number 3 is, how much will 27 pizzas cost? And number 4, the campers considered their budget. They only have $400. And they're buying from Royal. How many pizzas can they buy? What if they only have $96? So go ahead and answer parts 2, 3, and 4, and then come back to the video. So for part 2, 53 pizzas from Royal, that's one. So what I did is I went ahead and took, 100 from Royal is 1,200, and I divided that by 2, right? So 100 divided by 2 is 50, so 1,200 divided by 2, that gives me 600. And then we already know how many 3 pizzas cost, and that's 36. So 600 plus 36, so that's $636. Number 2, how much will 27 pizzas from Howdy's cost? So for the 27 pizzas, there's a couple different ways you could do this. Like you could take, let me highlight this a different color. You could take 20 plus 5 plus 2 to get that total cost of 351. So for number 3, your answer is 351. And there's multiple ways to go about getting that, but if you look in the blue highlighted, I took how much 20 pizzas cost plus how much 5 pizzas cost plus how much 2 pizzas cost to get So for number 3, I was looking at the price of Royal, but they're actually asking for the price of Howdy's. So that's highlighted in purple here. It's 260 plus 65 plus 39. Okay, so for number 4, it says the campers consider their budget. How many pizzas can they buy from Royal with $400? So they only have $400. We know that each pizza costs $12, right? So probably the easiest and most direct way is to go and divide those. So if I have $400 and each pizza costs $12, that will allow me to purchase 33 1/3 pizzas. But they're not going to sell you 1/3 pizza, so maybe you can get a small salad. But otherwise, you can only get 33 pizzas. Okay, you could also use the rate table above to try to figure that out. That's entirely up to you. Like if you look at this, this is at which one? Royal Pizza. So you could do, $240 will give me 20 pizzas, and then another 120 will give me 10 pizzas, right? So total, I've spent $360. So I have $40 left to spend. So I can't buy 4 pizzas because I don't have 48, and I can buy 3 pizzas because I have 36. So I can buy 3 more pizzas. 3 more pizzas at the price of 36. So I bought 20, then 10, and 3, which is 33. So either way, you could do those using the rate table or understanding how much one pizza was. And then if you only have $96, you would do the same thing. You would take 96 and figure out if each one is 12, how many could you purchase? And you would be able to purchase 8. But you also notice that if you take 60 plus 36, that gives you 96, which equals 8 pizzas. Now on part B, it says on number 1, if you know the price of one pizza, how can you find the price of additional numbers of pizza? Go ahead and answer 1, 2, and 3 on part B, and then come back to the video to see how you did. All right, so number 1, all you would have to do is to multiply the cost of one pizza. So if, for example, if you know the cost is $12 and you want to purchase 25, or let's say 100 of these, even to keep it simple, right? You would just multiply those together. So that would cost you $120. So write that in words. All you do is take the cost times however many pizzas you want to purchase, and that'll give you the total cost. Number 2, for each pizza place, use your strategy from part 1 to write an equation for the total price for any number of pizzas. So in number 2, let's do the Royal first. So the Royal, so there's only one L, but the cost would equal 12 times the number of pizzas. And then for the Howdy's, the cost would equal 13 times the number of pizzas. Okay, you could write it out like this, or, if you know C is cost and P is pizza, you could do the cost is equal to 12 times the number of pizzas. And then for the other one, the cost would equal 13 times the number of pizzas. So either one of those is good. This is where we're going, but you have to make sure that you identify what the C and P represent as well when you write those out. Number 3, how does your equation help you solve problems such as those in questions A, part 4? And part 4 was asking about, hey, if you know that you only have $400, right? So in 3, if you only have $400, that's the total cost. That's all that the pizza can be. And so 400 would have to equal 12 times P, or the number of pizzas. So to figure out the number of pizzas, you ask the inverse question, meaning instead of 12 times what number gives me 400, 400 divided by 12 gives me what number? And that's what we ended up doing, is taking 400 divided by 12, and that's where we got 33 1/3. Okay? So you could set up the equation for any amount that you have or any number of pizzas that you want. Now in part C, Howdy's listed price is valid only if you pick up the pizza. If you request a delivery chart, they charge $5 flat fee. So here's another table, and that's $5 flat fee. That means not if you order 100 pizzas, it's still $5 delivery. 2 pizzas, $5 delivery. All right, so go ahead and find your lab sheet and fill out this table below. Here's what your lab sheet looks like. Let's go ahead and fill out that table. So these are the prices that we already know, but now if there's a delivery charge, all of these above are just going to be $5 more. So we would just add $5 to all of these costs. Okay, that's your table. And now it says describe the patterns you see in each table in part B of this question. And if you haven't answered this, go ahead and pause the video and answer this question. By looking at the patterns, right? If you look here from 1 to 2, that's plus 13. From 1 to 2, that is also plus 13. So you notice they're both going up by 13 every single time. Regardless of whether you're priced for pickup or delivery, the cost of pizza still increases by 13 every single time. In part C, it says in question B, part 2, you wrote an equation for the cost of the pizza. How does the information represented by the equation show up in the table? Right? Because remember, for the first one, it was the cost is equal to 13 times the number of pizzas. And so this 13 shows up right there. It shows up as the change from 4 pizzas to 5 pizzas, 5 pizzas to 6 pizzas, and so forth. So this is the change in cost depending on how many pizzas you purchased. Number 2, on the same coordinate plane, plot the data for Howdy's prices with no delivery fee and with the delivery fee. So you're going to be doing these. So I would get 2 different colored pens or pencils. So let's do the price for pickup in this color. And then we're going to do the price if Howdy delivers in this color. So let's go ahead and graph them down here on your chart. So if you need help getting started, I'm going to go ahead and grab the purple and do the price for pickup, right? If you pick it up, because if you order 1 pizza, it costs $13. So over here at 1 pizza, I'm going to go up to 13 and I'm going to put a point. 2, it costs 26, so I'm going to put a point there. So go ahead and do this on your own for both the price for pickup and if Howdy delivers. Okay, when you graph those, this is what those should look like. You notice the price for pickup in the purple there is always 1 step below, just a little bit below. In fact, it's going to be $5 below if you're looking at these. It's going to be 5 below each one of those. Okay, so that's what our graph looks like. It says, how are the graphs similar? How are they different? Number 1, they're similar because these lines are parallel. And what I mean by that is if I draw a straight line as straight as I can through each of these, those lines, okay, go up at the same rate. So we would say, number 1, those lines are parallel. Okay, and then how are they different? Well, the price if Howdy delivers is always $5 more than the price for pickup. So that's how they're different. They're always 5 units apart vertically, right? So this light blue line is always 5 units higher than the other one. And then for each graph, which coordinate pair represents how much 1 pizza costs and how much 0 pizzas cost. So for 1 pizza, the correct coordinate pair would be these right here. So this one and this one. So right here for 1, it was at 18. And here for 1, it was at 13. And then for 0, this line would continue to be right there. So for the price for pickup for 0 pizzas, it would be 0, 0. But if you were to have them deliver it, it would be 0 pizzas, but you would still pay $5, right? Because the delivery itself is still $5. Okay, that is all that I have for comparing pizza prices and scaling rates.